All right, good morning, everybody. So welcome again. We're studying lesson 4.3, higher degree polynomials, polynomial functions, and graphs. So today we're going to learn about basically the multiplicity. We'll get into the multiplicity. Which is basically how many times the answer repeats itself, right? Number of times the zeros repeat. What do I mean by zeros? I mean the x-intercept, right? You know how we set the y, we set the y equal to 0? You know that? Well, exactly. When we set something equal to 0, and then we solve for the x, those are x-intercepts. We're also going to look at the max number of extremes and the max number of zeros, right? Max number of zeros, which again are just the x-intercepts, are basically the degree of the function minus 1. So if you have f of x is x squared, you know that the degree of the function is 2. And so the max number of zeros equals the degree of the function. I got ahead of myself. It is equal to the degree, not degree minus 1. For the next one, it is the degree minus 1. And that's for the max number of extremes. Max number of extremes. Now this is the degree minus 1. Right? So what are extremes? They're turning points. So basically, if you have a graph like, y is x squared, right? As you can see, now here I have one turning point, because here it is going, if you're reading this from left to right, this is a negative slope, and then this is a positive slope there. So it has one turning point here. It also has one x-intercept, but it could have had 2. Remember, it can equal the degree of the function. So if my graph would instead look like this, as you can see, it still only has one inflection point, one turning point, right? It has one extreme, right? Because the degree is 2, and 2 minus 1 is 1, right? So the number of extremes is the degree minus 1, which is 2 minus 1 is 1. And as you can see, it has one turning point, but it has 2 zeros. Again, zeros are x-intercepts. As you can see, it has two zeros. Two of them. All right. So let's get into it. We're also going to learn about endpoint behavior, and I'll get into that later. Number 1. So I hope you're following along with me. Number 1 is, without graphing, determine how many extreme points are in the function and find the y-intercept. So we're not allowed to graph it, and our graph or equation is this. right? And we want the number of extreme points. Well, I know that the degree of the function, right, extreme points depends on the degree, which in this case is 8. So how many extreme points do I have? Well, then let's look back at our notes. Extreme points are degree minus 1. So it is 8 minus 1, which is 7. But it could have less. It could have 7, 5, 3, 1. Right? So that is the answer. So if I'm looking at the notes here, right, it doesn't exactly explain why it goes by 2 down, but that is the answer. And the y-intercept is nice and easy. Again, if you plug in, if you set x equal to 0, you will find the y-intercept. So when x is 0, we have 3 times 0 to the 8th minus 4 times 0 to the 5th plus 3 times 0 plus 1, as you can see, right? The function will equal 1 when the x is 0. So your point is 0, 1. This is your y-intercept. Is that a negative sign? Sorry. Negative. So your point is -1. I just wrote it wrong. So yeah. Very good. Number 2 says the function is graphed below. Find the maximum, relative max. So your function is graphed like this. And it wants me to find the relative maximum. Well, that point's right there. Relative max. All right? So I believe for number 2, if I put it on preview, give me a sec. Oh yeah, so it's interactive. It literally gives you the answer if you hover over it on student view. So in your view, you're able to see the answer, which is, right, you could just see that it's 2.81, comma 1.09. So on the teacher view, I wasn't able to see that, but you guys are. All right, I'm gonna get out of this teacher view or student view. And I'm back. For 3, it says, the function is graphed below. Use the graph below to find the relative minimum. And again, the relative minimum would just be for number 3 right there. So hover over and your answer should be 1.2, comma, -1.1. Number 4 says the function is graphed below. Use the graph below to find the y-intercept. Okay, so the y-intercept for this graph would be right here because it crosses the y-axis there. So for number 4, hover over there and you shall find your answer. Number 5, And that was 0, 4. Number 5 is determine the sign of the leading coefficient and whether the function is even or odd. Okay, so now there's some learning here. So basically, you have this cool end behavior chart. All right? And you have basically positive leading coefficient, so positive, and we're talking about the leading coefficient. So and then we have the negative leading coefficient. We also have an even degree. We're talking about the degree is even or odd, right? And so it tells us this is what it looks like if it's even with the positive leading coefficient. So I'm gonna call that 1. So for case 1, we have something like this. We have something like that, right? Y is x squared. The leading coefficient is positive, and it looks like that, and it's even. See how the 2 is even? Okay, it has an even degree. Now for case 2, let's say it was even and negative leading coefficient, and it will look like this. Well, that makes a lot of sense for case 2, because it will look like this. All right? And that is for y is negative x squared, because that will flip it, right? Reflect about what axis? The x. Okay. What about case 3? For case 3 is odd, but if it's a positive leading coefficient, it's going to look something like what we just saw. It's going to look like that, right? This is y is x cubed. This is a parent function, right? Same as this is similar to parent. This is a parent. So yes, as you can see, it's positive and odd. Odd degree, positive leading coefficient. Number 4, for case 4, they're just switched. So this would be case 4. It's going to look like, right? And so basically you just added a negative sign. So whatever was here on top is now going to be here on bottom. And as you can see, there it is. So this is y is negative x cubed. This is odd. And this is negative. That fulfills case 4. All right, so you could tell a lot about a function just by its end behavior. Number 6. Determine the sign of the leading coefficient, whether it has an even or odd degree. Easy. It looks like this, right? And we already covered that's case 1. That is a even degree and positive leading coefficient. All right. Number 7. It says, using what you know about end behavior, which one would match it best? Well, if f of x is 2x to the 6, and then all the rest of the terms are not that important. All I care about is that this is even and this is positive. And so I know the end behavior will look like this. And the only one that really matches that is A. So the answer is A. All right. Number 8. Number 8 says using decimals, graph the function below and state how many zeros the function has. So I need to go to student view. For number 8. All right, it says if you graph it, you have x cubed minus 2x. All right. It's interesting. Very cool. So basically, I have zeros at, if you can see the function is -1. Right, so I'm just gonna basically tell you how it looks. It looks kind of like oh, actually, like that. Right, so it has a 0 here, here, and here. All right. So this is not too hard to do. I think you guys could do this on your own. I'll give you the answer for 8. That will be the function has 3 zeros, as you can see. So 3 zeros. They are, right, the x-intercepts are -1.4, 0, and 1.4. Okay, number 9 is the same. Number 10 says f of x is x cubed minus 2x squared minus 15x. Write it in factored form. What are the zeros? So this is interesting, right? In order to find the zeros, you got to set y to 0. So now I could factor out an x, and we're left with x squared minus 2x minus 15. All you got to do is whatever you're factoring out, you divide by that. So I'm going to divide x cubed by x, and I will get x squared. That's how I do things. Next, I'm going to have a times c up here, b down here. A and c, remember this is your a value. This is 1. This is your c value, which is -15. So then this is your b. So 3 and 5 come to mind. Has to be -2. So now we get, I'm going to bring down the x times, and then here you see that the a is 1, so we get very easy results. We get x plus 3 and x minus 5 from here. That's it. And remember, this equals to 0. So by the ZPP rule, we know that if this was 0, That'd be great, because 0 times all of this will still be 0. So that would work. So what does x have to be? 0. Now if x plus 3 right here was 0, that'd be great. So x is negative 3. And if x minus 5 was 0, then x would be 5. So those are your answers. Number 11. Write the polynomial standard form with zeros at these guys. So this is just the reverse. This is very fun. The x-intercepts are at -4, -2, and 1. So that means you have x plus 4, right? Because remember, this whole thing is equal to 0. So therefore, if this was 0, that'd be great. X plus 4 was 0, so the x is -4, which is the same that we got there. So that lets me know that this is correct. Times x plus 2. All you got to do is flip the sign. That was negative, then it's positive. This is negative, then this is positive, right? And x plus 1. So now, it says to write in standard form, we got to multiply it out. So I'll do x times x, and then x times 2, x squared plus 2x. Then 4 times x, and then 4 times 2, plus 4x plus 8. And then combine like terms, these and these. And then bring this down. All right. And then you're going to multiply that out. So I'm going to do x squared times x, and then x squared times 1. We're going to x cubed plus x squared. And then 6x times x is 6x squared, 6x times 1. Right? Going to combine like terms. We have x cubed, couple squareds here. Right? And let's see what we get. I mess up somewhere. Oh my goodness. Sorry guys. This is a minus. -1. Forgot to remember this was positive, so then this one has to be negative. Everybody makes mistakes. So, all right. So I'm going to change some of these. That is every third term. So we got this one. We got negative x squared is supposed to be. Oh, second term. Okay. Here, how about I just do it again? It's gonna be hard to erase. Sorry, guys. So we have x cubed minus x squared combine like terms. All right, let's see if that matches 3. So we got 152 negative 8, 152 negative 8. Yep. Number 12. All right, number 12. Identify the zeros and state their multiplicity. All right. So for this guy right here, let's get the zeros going. Remember, set y to 0 to get your x-intercepts. Those are your zeros. So if this was 0, that'd be great. X plus 7, that'd be great if it was 0. Right? So then x is negative 7. It'd be great if this was 0 too. Right? 2x plus 1. If that was 0, then x is negative 1 over 2. And then if this was 0, that'd be great. X would be 4. Now remember, we have 2 of these guys. We have 1 of these and 3 of these. So in reality, your x values are negative 7, negative 7, negative 1/2, 4, 4, and 4, because there's 3 over there, right? Those are your values. So the multiplicity here is, right, for negative 7, we have 2 of them. We have, for the negative 1/2, we have just 1 of them. And for the 4, we have 3 of them. Right? So there you go. And the effect, remember, if very important, if multiplicity is odd, it crosses. Okay? If it's even, it bounces. Right? I'll give you an example. Like, let's say that your graph looks like this. Well, you know that this is something along the terms of y is x squared, along the terms of that, right? And you're allowed to have up to the degree of the function number of zeros. Here, the degree is 2. So you're allowed to have how many zeros? The max number of zeros is 2. And here we have it, 1, 2. But because these are different, like let's say the x-intercepts are at negative 1 and 1, the multiplicity for each is 1. So therefore it crosses, as you can see. We have an it equals 1 for each. At x is negative 1, you have 1 of them. At x is 1, you have 1 of them. So therefore it crosses, since they are odd. This is odd. Multiplicity is odd, and if it is odd, it crosses. In another example, like let's say you had something like this, right? This is y is x squared. This is exactly that. This one up here was something different, like minus 2, whatever, right? This could have been like negative 2. But here, this is y is equal to x squared. And if we set that equal to 0 to find the zeros, we have, well, if this was 0, that'd be nice, right? Well, basically just solve it. We're going to square root both sides, and we get x, right, because these cancel, equals 0. But it's plus or minus. It's still 0. So basically, you have one x-intercept right there. Right? So you had plus or minus 0, plus or minus 0. So your results are positive 0 and negative 0, right? These are your results. So the multiplicity, right? This is the same number happening twice. So this is multiplicity is times 2, which is even, and so it bounces. And these are two examples of one when it crosses because the multiplicity is odd, and one where it, right? So this one crosses because it's odd, and then here the multiplicity is double, right? And so it's even, and it bounces. Okay. For number 13, so I could let you guys go. It says for the function below, find any multiple zeros and state the multiplicity. Again, easy peasy for 13. Okay, so they just try to trick you here. These are the same here and here. We have 3 of them, right? We have 3 of them being multiplied, so there it is, cubed. So what does this tell you? It tells you that if this was 0, remember, set equal to 0, y equal to 0 to find the x-intercept, which are the zeros. And we have x minus 2 is 0, and x plus 1 is 0. X is 2, x is negative 1. How many of these do we have? 3 of them, right there. How many of these do we have? We have 1, right? Times 1 of those. So these are both odd. So they both cross. So it's asking for this one because it says find any multiple zeros and state their multiplicity. These are multiple zeros. There's 3 of them, right? And the multiplicity is 3. So that's your answer. You will plug in negative 1 and then has a multiplicity of I believe, to be honest, that they messed up on this one. Yeah, because I don't think they were trying to trick you. I think they just messed up. This one, they wanted it to be negative. So I believe you guys can do that on your own. I'm going to switch this one to a negative so they can have what they wanted. And then you guys can plug in the right answer. Okay, so this one, canvas error. Okay, for 13. All right. Thank you for watching, and I'll see you in the next one.